welcome to this video. So we continue solving questions on integration. Okay, so the next question, they're saying the figure below shows a sketch of part of the curve with the equation, this equation here. Okay, and you see that in this equation we have k. So they're saying where k is a real constant to be found. Okay, and then they've given us a presentation in this curve here. You can see the x or y plane. You can see this curve starts from 0 and then it goes like that. So this is the curve C. So on the curve C, we have this point P, okay? And then on the y-axis, we have this point N, and then this N and P are joining by this line here. All right, so the first question, they're saying find the dy dx. So our y is x to the power 3 plus 10 x to the power 3 over 2 plus kx. So we want to find the dy dx here. So dy dx will be equals to, the power drops, 3x, and then it reduces by 1. Okay, even here it will be the same. So it will be 3 over 2 multiplied by 10x, and then 3 over 2 minus 1, I get half, plus here, just be k. Okay, so that's the derivative that I have there. And then here I can multiply it, so it will be 3x squared plus 3 multiplied by 10, it's 30, divided by 2, it's 15x to the power 2 plus what? K. So this is my derivative, right? Okay, so we can keep it somewhere. So we're going to say our dy dx, we found it to be 3x squared plus 15x to the power 1 over 2 plus k. We've done part 1, and then part 2, they're saying the point P, okay, this one here, on the curve is the minimum point. Given that the x coordinate of P is 4, we can even see when we go up here, it's on 4. So P is 4 comma something, okay? Show that K is equals to minus 78. So we have to know that when they say P on the curve is the minimum turning point, okay? So at the minimum turning point, or at any turning point, whether it's maximum or minimum, your dy dx is always equals to 0. So I'm going to equate this dy dx to 0 plus k will be equals to 0. But now they have told us that the x coordinate, okay, is what? 4. So wherever there's x, I'm putting 4. So this is x to the power half. Power half is the same as the square root, and the x is 4. And then plus k is equals to 0. So it means my k will just be equals to, this here will be 3 multiplied by 16, which is 48. So it will be minus 48 this side. And then here to be 15 multiplied by the square root of 4, which is 2. So this will be 30. So minus 30, which will just give me minus 78. So we've shown that k is actually equals to what? Minus 78. All right, let's do the last part. Okay, so we've shown that k is equals to minus 78. So the last part of the question, they're saying the line through P parallel to the x-axis cuts the y-axis at point N. Okay? The finite region R is bounded by, so this region R here, which is shaded, is bounded by the curve, okay, the y-axis, and the horizontal line, this one here, that connects N to P. Okay, use integration to find the exact area of the shaded region R. So now, the shaded region, okay, of this R will just be the area under this curve from this point to this point. So this point, x is 4, this point, x is 0. So it will be the area under this curve from 0 to 4. But remember, we have this horizontal line that is bounding it. So we are going to subtract this horizontal what? Line. So this horizontal line here, we can find its value, okay? Because we can just use we can use the equation of the curve, Okay, so we know that at this point, okay, at this point, the at this point, the all right. So I was saying at this point here, we see that our x value is 4. So this curve passes through this point. So how can I find my y value at this point? Okay, my x is 4. So I'll use this equation. My x is 4. So it will be 4 to the power 3 plus 10x. My x is 4 now to the power 3 over 2 plus, remember the value of k that we found, minus 78. And then x is 4. So we have to evaluate this. Okay, so when we evaluate this, I'll just punch them direct into the calculator. I'm finding minus 168. So it means at this point, the y is minus 168. Okay, so now since this is the horizontal line like that, it means this line here, the line NP is just equals to minus 168. Okay, so to find now the area which is bounded by the curve, the y-axis and this line, we're just going to say the area shaded is the same as the area of this curve from 0 to 4 minus this horizontal line here. Okay, because it's been bounded by the horizontal line. So we're going to say area of the region R is equals to the integral from 0 here, the x, to 4, okay, of this curve. So what is this curve? This curve is given by x to the power 3 plus 10x 3 over 2 plus the value of k was what? Was minus 78. So we can say minus 78. So this one here is at has replaced this k. And then I have x, okay? Uh, and then I have to subtract. Okay, so before I put the brackets, so from this equation, I have to subtract the horizontal line, which is just minus 168. Okay, so now I can put this in brackets and then I say dx. So that will be the area that is shaded there. So it will be equals to, okay, the integral from 0 to 4 of x to the power 3 plus 10x 3 over 2 minus 78x. Okay, and then minus 68. So it means there I'm just going to have what? Plus uh okay, plus 68x. Oh, no, plus 68. We haven't yet integrated. And then now we can integrate this. Okay, so I'll erase what I have on top. Okay, so now let's integrate this. We're going to have what? We're going to have x to the power 4 over 4 plus here it will be 10x, so power plus 1. What are we going to get? So we can say 2 over 2. 2 over 2 is the same as 1. So it will be 2, 5 over 2. So it means the new power here will be 5 over 2. Okay, and then we divide by that same new power. So it will be 10x to the power 5 over 2 divided by 5 over 2. This is the scenario that we're going to have there. Okay, so how can we best deal with that? Okay, how can we best deal with that? We're going to say that is the same as, we can divide these two coefficients. So it will be 10 divided by 5 over 2, which is the same as 10 multiplied by 2 over 5, which is the same as 20 over 5, which is just what? 4. So this whole thing here becomes 4x to the power 5 over what? 2. Then when I integrate this guy to be minus 78x squared over 2 plus, if I integrate this to just be 68x, and then the limits are 4 to 0. Okay, so we see that one of the limits is 0. Okay, so if one of the limit is 0 here, if I put wherever there's x, if I put 0, 0, 0, I'm just going to get 0. So we're not going to count the one for 0. So we're just going to subtract, to substitute 4, I mean. So here to be 4 to the power 4 over 4 plus 4, and then there to be 4 to the power 5 over 4 minus 78 divided by 2, it is minus 39, 4 squared plus 168, 4. Okay, so now I'll just punch this onto my calculator. All right, so when I do this, my final answer is simply 240 units squared. All right, so that will be my area for the region what? ARA. And we are done with this question. So in this lesson, we're going to look at how to find the area bounded between two, the area bounded between a line and a curve. Okay, so let's read the question. So they're saying the finite region R, we can see this region here that is shaded, is bounded by the straight line L, okay, with the equation y is equals to 4x plus 3 and the curve C with this equation here. Okay, so the sketch for the curve for the defined domain is shown below. So you can see this one here. So you can see this straight line here is the one they are calling L. And then we can see this curve that comes like that. Okay, it's the one which is being given by this equation. Okay, so they are further on saying the line L meets the curve at the point A. So this is the point A there, okay, on the y-axis, and L meets C again at the point B. So that's the point B, okay? So the first question is, use algebra to find the coordinates of A and B. So for us to find the coordinates of A and B, we just have to solve this equation of a line with this equation of a curve simultaneously. Okay, so we're given that y is equals to 4x plus 3. We're going to get this guy and substitute where there's y in this equation here. Okay, so the other equation is y is equals to 2x to the power 3 over 2 minus 2x plus 3. So where there's y here, I'm going to put this 4x plus 3. So it will be 4x plus 3 is actually equals to what I have here. So 2x to the power 3 over 2 minus 2x plus 3. Okay, then from there we can say we can put like terms together. Okay, we can put like terms together, or we can simply put everything on the left-hand side. So I'm going to have 4x. This one comes to the other side. It's going to be 2x. Okay, and then I have this guy, which becomes a minus when it goes to the other side, right? So it will be minus 2x to the power 3 over 2. And then what else? We can say this 3 is positive. So when this 3 comes to the other side, what are we going to remain with? Okay, we're going to remain with 0. So this will be equals to 0. Okay, and then from there, we can say this here will just be 6x minus 2x to the power 3 over 2 is equals to 0. Okay, from there, we can factorize what is common here. We can factorize x, okay, or 2x. Remember, this one here, the x to the power 3 over 2, okay? 3 over 2 is simply 1 plus half. So this one is the same as x, okay, to the power 1 multiplied by x to the power half. So if I add 1 and half, I'm still going to get this, okay? So if I factorize 2x from this whole expression, let me erase what I have here on top. Okay, if I factorize 2x from this expression, what am I going to get? This one here. Okay, if I factorize 2x here, I'm going to remain with what here? 3, right? Then minus, remember this part, okay, can be written as I can even put 2 in front. It can be written as this. So if I factorize 2x, I'm going to remain with this. So here to be x to the power half is equals to 0. So that is what I remain with there. And then from here, we can equate this to 0 to find the value of x. We can also equate this to 0 to find the value of what? X. Okay, so if I equate this to 0, it means my x will just be 0. If I equate this to 0, it will be 3 is equals to x to the power half. Okay, so what do I do here? I raise both sides to the power 2. So here it will be 9 is equals to, here to be 1 over 2 multiplied by 2, which will just be 2 over 2, which will just be 1. So we remain with x. Okay, so x has two values. X is equals to 0 and x is equals to 9. And it's true that x is equals to 0 because they said this point x is on the what? Y-axis. And we know that in the y-axis, x is always equals to 0. Okay, so we found the x coordinates. Let's now find the y coordinates. So the y coordinates, they won't be difficult. Okay, we can use any of the two equations. If you want to use this one, if you want to use this one to find the y coordinates. So we're going to use the simpler one. So y is equals to, if x is equals to 0, then y will be equals to 4 multiplied by 0 plus 3, which will just be what? 3. So it means the coordinates of A will just be simply 0, 3. Okay. And then if x is equals to 9, then y will be equals to 4, 9 plus 3. So 4 multiplied by 9, it's 36 plus 3 to be 39. So it means coordinates of B will just be 9, what? 39. So we found the coordinates of A and B. So now we move to the next question. Okay, so the next question, they're saying use integration to find the exact area of the shaded region R. So this region is between these 2 points here. All right, so if we were to use calculus here, okay, then the area of a shaded region will be the area of the line that is above, okay, minus the area of the curve that is below. So if we were to find the area, okay, from this point to this point here, okay, if we were to find the area that is below this line, it will be this whole area here. That will be the area below the line, okay? And then if we are to find the area below the curve, it will just be this area here. Remember, we are just ending there. It will be this area here. So to find the area of the shaded, we have to subtract the area of the region under the line, okay, which was everything, minus the region under this curve, which is just this part. So it will leave us with this shaded part, which is referred to as what? R. So we're going to say the area of the region R is equals to the integral, okay? The x here at this point A is 0. The x there is 9. Okay, so we are subtracting the line and the curve. So it will be the line, which is just 4x plus 3, okay, minus the curve, which is 2x to the power 3 over 2 minus 2x plus 3. And then we're finding dx. So that will be the area there. Okay, so from there, we're going to say this is equals to 0 to 9. It will be 4x plus 3. And then here we can distribute this negative. So it will be minus 2x to the power 3 over 2. This negative and this negative, it will be plus 2x. And then this negative with the 3 to be minus 3x and then dx. So 0 to 9, 4x plus 2x to be 6x. This 3 and the minus 3 will cancel out. Okay, so I just remain with minus 2x to the power 3 over 2. So this is the part that we are integrating to find our what? our area of the region R. Okay, so we're going to say, let's integrate this. So when you integrate this, you're just going to be 6x squared over 2. Okay, remember we add a 1 to the power of x, and then we divide by the new power. Okay, so here we're going to do the same. So it will be 2x. If I add 1 to this, okay, I'm going to get 5 over 2. So that will be the new denominator like that. And then I can put the limits 9 to 0 or 0 to 9. Okay, so let's simplify this part here. Okay, so let's get the coefficients here and leave the x alone. So it will be 2 and then divided by what? 5 over 2, which is the same as 2 multiplied by 2 divided by 5. So to be 4 over 5. So what we have here to be 4 over 5. So it is like this will of course to be 3x squared minus this will be 4 over 5x to the power 5 over what? 2. And then of course we have the limits 9 to 0. So here there will be no need for you to substitute the limit 0 because it's going to give you 0, 0, 0, 0 everywhere. Okay, so we're just going to substitute the 9. So we're going to say this is equals to 3, 9 squared minus 4 over 5. And then the x is 9. And then the power 5 over 2. Okay, so this will be 3. This will be 81 minus 4 over 5. And then this 9 here to the power 5 over 2 is the same as the square root of 9 to the power 5. Okay, right. So square root of 9 is 3. And then 3 to the power 5. That's what we have here. Okay, so you might need your calculators there. So let's punch that. Okay, so the area will turn out to be 3 multiplied by 81. And then minus, so 3 to the power 5 is giving me 243. Okay, and then here now we can just punch this direct into the calculator. Okay, it's giving me 243 over 5. And since it's area, it will be units squared. All right, so we are done with this question. So I got this question from the Unilus tutorial sheet for semester 1. Okay, so if you'd like to access the full video where I'm solving all the other questions that you can see in these tutorial sheets. Okay, so all these questions, I've solved them and there are videos where I was explaining them. Their videos are there on our website. Okay, so just check the link below here. You're going to find the link to our website. Okay, and then there, when you enroll, you're going to access the video, the full video, okay, to all these questions that you can see in this tutorial sheet. Okay, so it's not only this tutorial sheet, we also have videos on all the other tutorial sheets as well. Okay, so you are going to find the videos there, and then you can learn easily and at your own time, at your own pace. Okay, so thank you so much for watching this video and goodbye.